In the second part of today's lesson, we're going to talk about three-term and four-term polynomials. In three-term polynomials, you always want to look for the greatest common factor first, just like we did in the last video, and then you're going to check for two things. You're going to check and see if you have a perfect square trinomial or if you have a regular general trinomial. So perfect square trinomials are when the first and last term are perfect squares. And when they are perfect squares, then what you can do is write the first, or you can write a plus b to the second power. So these are our two formulas you want to make sure you write down. Notice that one has a positive, one has a negative, and that's all going to be dependent on what your middle term is. So note if it's a plus, it's a plus sign in the parentheses. If it's a minus in the parentheses. The other thing to note is that when you write something as a quantity squared, that's the same as writing it twice. So a plus b times a plus b. Same with this one, it'd be a minus b times a minus b. So same quantities written twice. So let's go ahead and do our first example. We have 6d squared plus 7d minus 3. Remember, always check for greatest common factor first, which that does not have anything, so we skip that step. Then second step is to look and see if it's a perfect square trinomial. So we need to look at the first term and the last term. Neither of those numbers are perfect squares, so we know that it's not going to use the perfect square trinomial rule. So that means that we are going to factor this one as a regular polynomial. So to factor a regular polynomial, we know we have to split the squared term up. So we're going to have d and d in both the first places. We know our factors of 3 are 1 and 3, so we're going to put a 1 here and a 3 here. However, we also have to think of the factors of 6. So our factors of 6 are 1 and 6 or 2 and 3. And we want to figure out which ones are going to go in front with both of our variables. So I'm going to go ahead and start with the 2 and the 3. You can pick whichever one you want to start with first. So the goal is to get this so we could get a positive 7 out. So if I put a 3 here and a 2 here, I can check by doing my smiley face. So the outside would get us 9d, and the inside would get us 2d. Notice it looks kind of like a face. 9 and 2 can get us 7 if we subtract. So that means that the 2 has to be a negative, and the 9, or the two 3's, have to be a positive. And then we can just make sure that all of our signs work out well. If we multiply -1 times 3, we do get -3, so we are good to go. So anytime there's a number in front of your squared term, you're going to have some numbers in front in your factors, and that's the part people tend to forget, so be very, very careful with those. Now the last example of the 3 term, when we look at this one, remember, still look for greatest common factor, which there is not. Then we want to see if it's a perfect square trinomial. So always look at the first term and the last term. First term can be written as a perfect square, and so can 81. So since these can be written as perfect squares, we know it is a perfect square trinomial, so we're going to go ahead and factor it as such. So when we factor perfect square trinomials, we're going to have the same terms in both set of parentheses. So we're going to break x to the 4th up into x squared and x squared. We're also going to break up 81 into 9 times 9 since they're perfect squares. And then our formula said earlier if it was all positives, we're going to make both of them plus. So this is our factored form. Now the easiest way to write this is to write the quantity squared since there are two identical factors. So that would be x squared plus 9 all to the second power. So this would be our final answer. Okay, so perfect square trinomials are really quick to factor as long as the first term and the last term are perfect squares. If they're not, it's just going to be a regular polynomial like example 1. Now in 4 terms or more, we want to usually look for the ability to group. Okay, so grouping is going to be a really unique factoring strategy when you have lots of terms. You still always want to look for the greatest common factor to start, but that won't always be possible. And so now we're going to go ahead and practice what this means when we are going to use grouping. So to make grouping easier, I've written 3 steps out for you off to the right. The first one is to group your first 2 terms and your last 2 terms together. So you're going to basically pair them off. Then you're going to factor out the greatest common factor from each of those pairs. and then rewrite your final answer. So in example 1 here, we're going to group the first 2 terms together and the last 2 terms together. And then we're going to go ahead and take out a greatest common factor out of each. So if I look at the first example, I can take out a 7 out of both of those, and that leaves me with 3 minus t. And then if I look at the second pair of factors, I can take out an r from both of them, and that's going to leave me with 3 minus t. Now the unique property of grouping is that what's in parentheses has to match. That's very important. Make sure you write that down. If they don't match, then grouping doesn't work. Okay, so if they match, then that's good. We can use this method, and now we can go ahead and rewrite our factors. So the 2 things that match, we're going to go ahead and write once, so 3 minus t, and then the last part will be the 2 things that are on the outside. So we have a 7 and an r, so our second term would be 7 plus r, and then we'd be done. So it can be very short. There's not a lot of steps to it, but it can be very tricky if you're not careful with taking out your greatest common factor, and if you don't get the things to match inside the parentheses. So always make sure inside the parentheses matches before you rewrite your final answer.